Hello everyone, I'm going to go ahead and dive into this week's lessons, and we're going to be focused on prisms, and we'll do some composites later in the week and pyramids as well, a little bit of changing dimensions. But it should be fairly similar because it's not going to be too much different than what we experienced when we did, I'm trying to get my pin to work, there it goes, even though it doesn't have my little pin symbol. Even though we're not going to be dealing with the circles as the bases, but more polygons. So today's May the 4th be with you day, so I hope everybody is well. So let's go ahead and get started. So what we're going to first look at is the differences between a prism and a cylinder. Of course, the basic difference is the cylinder has circles for bases. The prisms are going to have polygons for bases. And the prisms are named after their bases. Basically, a base is a polygon where they're parallel to each other, congruent parallel figures. So this is a base and this is a base. We have two bases. Sometimes it could get a little confusing with a classic rectangular prism on which one's the base, but don't overcomplicate it. With prisms, you have faces right here. These are going to be called our lateral faces. And even though these two bases are considered faces as well, you could call those our base faces if you want, or we just call them bases. We have our lateral edges, basically the edge to the lateral face. We have our base edges up here, so this is like a base edge right here. Alright, here we have a triangular prism, again named after the shape of the base. These are parallel and congruent. And we have our lateral faces. Let's get moving on. So formula of the lateral area of a prism is very similar to that of a cylinder. It is basically perimeter times height. So lateral area is equal to perimeter times height. In a cylinder, your perimeter was the circumference of a circle. Here, your perimeter is just the perimeter of the base. Now here we have a rectangular prism, and that could get a little relative on which one you want to call the base. But let's just keep it simple and put the bases here and here. Formula for surface area of prism, again, if you look on your star chart, it's going to look very similar. It's going to be perimeter times height plus the area of two bases. You're painting the whole box, the top and the bottom. Okay? So moving on, we're going to find the lateral and surface area of the prism. And just like I said in a previous video, you want to get all your ingredients out there. So you're going to find your perimeter, because your lateral area is equal to perimeter times height. And your total area, surface area, is equal to perimeter times height plus 2b. Right? I don't have my cursor. That's annoying. So perimeter is equal to just this right here. This is a 4 and this is a 3. So you add those two together and double it. So that is going to be 6 plus 8, which is 14. Your height is what connects the two bases. So this connects your two bases. And that is it. That's all we really need. We need the area of the big B for the total. That's just a rectangle. So that's 4 times 3 is 12. All right. And you're going to plug these numbers into here. So perimeter is 14. And we're going to multiply it by the height of 5. And that gives us 70. And this is going to be in square centimeters. Okay. And my total area, my surface area, often abbreviated SA or TA, is going to be that 70. We already found this. So 70 plus 2 times the area of the base, which the base is 12. That's 24. 70 plus 24 gives you, what? 94. 94 centimeters squared. Okay. So let's go ahead and keep on going. So we're going to run through this real quick. We've already talked. So we want to get all our ingredients written down. And that's perimeter, height, and B. Perimeter is just this right here, all added up. So basically 6 plus 8 times 2. And that gives me 28. Height is what connects the two bases. Area of the base, since this is a rectangular prism, this should say rectangular prism in the directions, is 8 times 6, which is 48. Okay. So there's your lateral area, perimeter, times height. That's an 8. So 28 times 2 gives me 56. 56 units squared. Total area is this right here, is perimeter times height plus 2b. Okay, so we got the perimeter times height is 56, and our 2b is just 2 times 48. And that gives me 152. Yes, my pen is driving me nuts. And that's going to be units squared. So let's talk about volume. So volume of the prism, in middle school you probably learned this, length times width times height, but this is only good for a rectangular prism, okay? And that's probably primarily what you dealt with. But in high school, it's going to be the same formula as you had for cylinder, the area of the base times height. So you need big B and you need an H. Now, big B can get a little complicated if we're dealing with some unusual polygons. But here we have a pretty basic one. So big B is nothing more than 48 because 8 times 6 is 48. 8 times 6 is equal to 48. I'm going nuts with this. Okay? And my height is what connects. The height is 2. So basically we have 48 times 2 is equal to 96. And that's going to be cubic. 96 units cubed. Okay. I don't know how much I can deal with this pen. Well. So, what we have is a triangular prism named after its base. Alright, so we need to find the lateral area, total area, and volume. For first, we need to have our perimeter, our height, and our big B. We need these things. Alright, perimeter is easy. That's 10 plus 10 plus 12. So that's going to be 32. Height is easy. It's what connects the two bases. Area of the base, you can use Heron's formula, which, well, being online learning, I don't think we've gone over that. So what you would have to do is, well, we have an isosceles triangle. So an isosceles is pretty easy to find. You drop your altitude. And there's an altitude right here. So if that's 12, this is 6. And what you have, grief, I need new stuff. All right. So there's a triangle. All right. This is 6. This is 10. A squared plus b squared equals c squared. It's a 3, 4, 5 triple. So what you have is 1/2 area base, which is 12, times height of 8. So 4 times 12 is 48. Okay. So area of the base is 48. So we plug it in. Lateral area is perimeter times height, right? So perimeter is 32 times 4, which is equal to a big old number of 128 units squared. This is lateral area. Total area is going to be perimeter times height plus 2b. So we got the perimeter times height is 128 plus 2 times 48. Oh gosh. One of these days I will improve this whole computer writing pad situation. Trying to make it to the end of the year before I make any decisions on what to get. Alrighty, for next year. So this is going to be 124. That's going to be 96 plus 124 is what? 128, 96. That's 14. I could grab a calculator, but I'm afraid to put my pen down. 11, 12, 224. Okay? Units squared. Volume is equal to area of the base times height, which is equal to 48 times my height of 4. So that's 160 plus 32, 192. And that's going to be units cubed. Alrighty? So let's go and take a look at a word application problem, which you'll be doing a lot of on Friday. So here you have a surface area of 448, and it's a rectangular prism. So remember, surface area is equal to perimeter times height plus 2b. We're going to plug in what we know and find what we don't. Now, if I were to draw one, okay, we would have a length of 14, width of 6, and a height we don't know. So perimeter is just 6 plus 14 plus 6 plus 14. That's going to be 40, right? So perimeter is equal to 40. My height, we don't know. And my area of the base, we do know because that's just 6 times 14. So that's going to be 60 plus 24, 84, right? 84. So we plug in what we know. I know 448. And I know perimeter 40. I don't know the h, but I do know 2 times 84 gives me a number. All right? So I have 448 is equal to 40h plus 168. Subtract 168 on both sides. I get 280. I'm pretty sure that's 280. 40h. 4 goes in 28 7 times. So kill the zeros and you get h is equal to 7. All right? So that is pretty much it for our prisms. I do have additional YouTube videos on this as well. I want to touch on Euler's characteristic. A lot of high school teachers call this Euler's formula, but actually Euler's formula is a relationship between the imaginary exponent of Euler's number and some trig, sine and cosine stuff. It's an actually pretty fascinating formula that I hope you get to encounter in your high school years. So I call it Euler's characteristic. Well, Texans call him Euler. The educated world call him Euler, all right? But he's Swiss, and if he wanted his name to be pronounced Euler, he should have spelt it that way, all right? Okie dokie. So basically, this is basically the faces plus vertices is equal to e plus 2. I never really wrote it this way. I always did faces minus edges plus vertices is equal to 2. I think that's the way a lot of people did it. That's the way I did it in my textbook when I taught at my other school. And this is just something interesting. It pops up on the SAT, and that's probably why we're touching on it. So here I have a triangular prism here, a pyramid. And if you want to look at how many faces we have 1, 2, 3 on the backside, and 4. So we have 4. Edges, we have 1, 2, 3, 4, 5, 6. And vertices, we have 1, 2, 3, 4 of those. And it should equal to 2. Sure enough, 8 minus 6 is equal to 2. So 2 is equal to 2. That checks. What we typically do is say we have a polyhedron with so many faces, so many edges. How many vertices does it have? And that's probably something you might see on the SAT. So I don't think it's going to be that common. Like for instance, I could say we have 8 faces, and we have, what should I give you? I'll give you 12 vertices, okay? Because we're looking at this hexagonal prism. And how many edges do we have? Even though you could count them. Well, imagine you didn't have a picture. So we'd just do something like 8 minus e plus 12. 12 is equal to 2. That's 20. Negative e plus 20 is equal to 2. Subtract 20, and you're going to have e is equal to 18. All right. So you'd have 18 edges to this thing. And you can count 1, 2, 3, 4, 5, 6, and 6 on the bottom, and then 1, 2, 3, 4, 5, 6 around the edges there. Okay, so that is pretty much it. I'm going to get this posted, and I'll do the pyramid one next.